All right, we are back. So the irony is like we keep ending up late every day. And the funny thing about like us being a little late today was me having to restart my machine because it was having weird issues, and today is the only time I didn't like install new stuff or updates before our stream, and that's the day I have to restart.
Have you restarted since you added those updates? That's the other question too.
Oh yeah, because I'm on Insider's fast ring, so it's several times a week. It's having me restart for something. So we made a couple of changes since yesterday. I've got everything hardwired, so I've got the Jetson hard Ethernet. Then I have both cameras on Ethernet, and it's kind of weird seeing myself over here.
You look kind of cool though. I mean, and it's drawing the box around you, which is nice.
Yeah. And then I've got us up here on the TV.
So I think it'd be nice if we walk through. I know we kind of implied this in module 2. Hey, look at there, tracking that car pretty nicely. That's cool. I know we made some changes to essentially account for. You've got 2 cameras showing now in your output, and I think even though we mentioned how to do that, I think it'd be really valuable if we start off just kind of showing like what those changes were, just in case folks might be interested.
Yeah, definitely. So in here, we needed to go into our services DeepStream config, and then we were running the YOLO v3 tiny. So do you want to walk through this, or you want me to walk through it?
Either or. I just remember, like, yeah. So the first thing was the tile display. And if you want to talk about like what the logic was behind, why we see your screen in the way that we do, I think that'd be valuable here.
Yeah. So you were just seeing. I'll just kind of switch back and forth between these as I explain them. So if we look at the output here, we can see that there's 2 cameras side by side. So when we're looking at this tiled display, we have the number of rows, and in our case, we just had 1 row, and then columns, so that we're setting them side by side. And then we've got the width and height if we wanted to adjust this so that we could have all of the videos bigger. And I think you said you're running 4x4, right? 2 rows with 2 columns each.
Yes, yeah. So it's one of those things, like once you add a new camera to your system, this is one of those things you'd want to, of course, be aware of, that you need to modify how it's displayed. And there's also another interesting thing we tweaked that was pretty important. It was down on the stream mux.
Well, also the important thing too here is, before we get into the stream mux, is we configured this source section, this source 0, with our RTSP stream yesterday. Everybody watched that. However, what did not exist is a source 1 section. So I copied this whole section, enabled it, and set it up. So we need one of these stanzas for each individual source. And then you were talking about our stream mux.
So one of the things I've found, and this is sort of mentioned on the NVIDIA forums, is when you're using multiple cameras, you always want to make sure the stream mux batch size is equal to, I've also found using multiples of works as well, the number of cameras that you have. And we sort of explained this on the first video. When you have a batch size of 2, that's essentially like on each execution cycle for DeepStream, when it's grabbing the frames, it's going to grab 2 frames. And since we have 2 sources, that's essentially 1 frame per source. Then it's going to run inference on those frames that it's captured. And if you don't do that, you'll find you might get some sort of performance penalties and things like that. We're finding even with this set here, we're getting a little bit of a frame drop, and we don't know exactly why. It's easy to point the finger at resource contention, perhaps because we're running a lot of things on the device.
Yeah, but I think it's probably a combination of things, right? So we have resource contention on the device. Maybe we have a bad device. maybe it's one of the cameras, right? Like I bought some cheap cameras off of eBay too, so they could be dropping frames. It could be a combination of all of the above.
But what we have is really good. And if we do, like, we just didn't have time to really dig into it deep, I think, before we started. But you can see, like, if Erik switches over to, the feed that he's got coming off of DeepStream right now, it's pretty clear. If you watch the timestamp, you might notice it's not like incrementing quite like we would like. You'd like to see it like smoothly, each second transition if you kind of watch the seconds over there. But I mean, this is good enough for today. And if we do resolve the issue, of course, we'll add a note in the documentation. But it's seeming like this might be because we've got a browser window open. We also have DeepStream running. We're also streaming the screen from the Nano to Twitch. So there's a lot of factors I think at play here.
Okay, so let's go back to our desktop. Okay, so we live source was 0, so I think we changed that to 1 as well.
That one should be by default, but that one is one too. That if you do start noticing performance issues, I've noticed toying with that live source equals 1 or 0, especially if you have older RTSP cameras that might not be indicating their timestamps. Some of them don't send that along with the stream data. You might find that you get better results by tweaking that, but we tried back and forth. I don't think we noticed anything on our side. It didn't seem to alleviate our error. So we'll come back to it. But I mean, I think we want it to be perfect, but this will definitely get us through the stream today. We want it to be perfect for y'all too. So if we figure it out, we'll definitely make a note in the comments.
Okay, so we got all this running. We're hardwired now, which the performance is a lot better, especially even in just like camera control. I can tell you that since plugging everything in Ethernet, it's significantly more responsive. I'm going to push this here and see whether it detects.
Oh yeah, it's like night and day from when we were doing this over Wi-Fi yesterday.
I'm trying to see whether I've got a Surface laptop here behind me. I'm trying to see if I open up the lid, whether it'll detect it. My chair is blocking it, but we'll mess with that later.
Okay. So now we've got cameras, and I guess for those of y'all following along at this point, you should have essentially a working DeepStream configuration more or less finalized. And there is one thing that we haven't done yet. You would hopefully have taken care of this in Module 2, but we're going to start actually pushing our data using. We're going to go into details on how the Stream Analytics at Edge module works under the hood, and we're going to redeploy it as our own, because up until this point, we're sort of using one from a foreign Azure subscription. And then we're going to build the time series insights backend in Azure to allow us to historically analyze that data. I see that there's also support for warm query syntax. So it's not necessarily full, it's not just archival. It's almost near real time if you want to think about it that way. And I think it made sense to put these two together. You'll see as we go along, they're very related because the Stream Analytics job shapes our data, and our data shape is very important to how we model things in time series insights. And so the first thing we're going to want to do, and this is all going back to that point of I'm telling you, all of these things are related. There's also a piece in the DeepStream config that's going to shape our data. And we're going to want to change that first. So you would hopefully have taken care of this when it was mentioned in Module 2. We're going to take care of it now. So Erik, in your DeepStream configs folder, we'll go ahead and run an ls and see what you see there.
Services, DeepStream configs. Okay.
And it looks like, trying to catch up to you, sorry. You'll see there's a file called messageconv_config.txt. And this is driving all of the camera data or what it's naming the sources, I should say, that are producing data within the DeepStream workload. So you'll see we've got this sensor 0. And if you were to log the output right now, you would notice that your source 0 is always going to be reporting with a sensor ID of camera underscore 0. And the reason why it is doing that is because it's actually defined in this file. So we're going to want to modify this because you have 2 cameras now. We want to modify this with an additional entry called sensor 1, and we want to name them appropriately. And this is actually going to cause an effect on how our data ends up getting visualized in time series insights at the very end of today's content. Now for naming, you could call them just a number, and it depends on what you're doing. I like to use like the location where mine are. So just that's up to you if you wanted to use like office or window.
So I guess, I mean, if we switch over to the Jetson here, I guess if we did some logs, Docker logs, then we should be able to see what it's detecting and then take a reasonable guess. Oh no, because I'm just thinking.
So yeah, if you hit like Control C here, this is actually a good example. You can see that the data is pushing out that sensor ID.
Yeah.
One of them is blank because we haven't defined it, and the other one, if you notice, I think if you scroll up a little bit, you'll see it's reporting as camera 0.
Okay, so in our case, then, if we go back to our desktop, camera 0 is the street.
Yep. And while that metadata for location and coordinate will be produced in the message, if you don't, so in the DeepStream config, we showed you can send a lightweight message or a heavy message. That data is actually not going to be sent because we've chosen the lightweight option. But if you wanted to, you could also pass along the location, the geo coordinates of the camera as well.
Okay, so we've got all this covered now. So now in those logs, we should have these assigned to where they are, which should make a lot more sense when we start kind of ingesting.
And the only thing we need to do now, since we updated that, is just restart the DeepStream workload. So we can restart the particular module, which is called NVIDIA DeepStream SDK. And now it's going to pick up, and if Eric was to log that as soon as it starts, it should show the new entries for the sensor IDs. And that's just a small thing. Like I would really highly recommend that you get this part right, because the sensor ID is going to be used as a partition key later on for our time series insights instance. And so you want to sort of know those ahead of time. And the reason I'm skipping ahead, just having the experience there, is that you can't change it after the fact. So,
you can probably, but you would just lose the data, right?
Right. And what happens, like you would end up with data that's going to stay in your time series insights, like with if you don't want camera 0 being reported in there, your options for removing it from your dashboard would be delete the time series insights and start it again, or wait until it expires. I think there's like a 7-day expiry period, or up to 30 days. It depends on how you configure it.
So it looks like we're up. I'll switch over here real quick so everybody can see this. Now we can see, if you can read very, very fast, we can see, we can see that we've got sensor IDs of office and street.
And so yes, and I just want to call out, that is like super important. So we'll maybe even update the documentation there in that intro to mention, make absolutely sure that your message conf config is appropriately set.
Okay, so we've got that. Now, what's our goal for today? What are we building?
We're going to recreate the Azure Stream Analytics job in our own Azure subscription instead of using the foreign subscriptions. Technically, my subscription is where that job's coming from right now. We're going to rebuild it and go into more details on how it actually works. And then we're going to, and because there's such a marriage between like the output of that job and what ends up in our time series insights dashboard, we'll then create the time series insights dashboard that will consume the data coming from our newly deployed Stream Analytics job.
Let me pull up the I've got too many monitors. I can never find where my mouse is. That's the disadvantage of having so many monitors. Okay, so we're on module 4.1. If you've been following along in the GitHub project.
Yep, and the first thing we'll do, we're going to head into Azure. We're going to actually create the Stream Analytics job on Edge in Azure. I know that's a lot of prepositions. But...
Stream Analytics job on the Edge on Azure.
In Azure.
All right. So we needed to go to...
so we'll go to your resource group that's been housing all of your services up to this point.
So this is all resources. We don't want to look at that. Avert your eyes. All right. Resource groups. What do we call this? Jetson? There we go.
Oh. That seems right.
There we go. Here's our storage account, our IoT hub, and our cognitive services. And so now we need to add a resource. And this was Stream Analytics.
And you want to make sure you look for the on edge. So this one is a little bit different than Stream Analytics in the cloud, which we'll use tomorrow, but just make sure you're on the right one. There's a big difference.
Okay, so let's call this, I guess we could just call it Jetson Nano, right? We'll just...
a good name for this, and I'm trying to think if it I don't think it actually matters, but let's call it DeepStream Analytics, since that's what it's going to marry to. Is that that's what we name the module in our deployment. We'll call it that.
Okay. So, and we've been in East, right?
That sounds correct. Yes.
I think I picked ECUS too. And hosting environment Edge.
Yes, and that part is super important. Make absolutely sure. And you might have noticed, I think when you clicked into that, it had cloud was default selected.
Yes.
So yes, make absolutely sure. And then to keep costs down, you can actually dial down the streaming units. No, I'm sorry, you don't have streaming.
It doesn't give us that option for Edge.
That's right. So yeah, so that should be all you need. And it's kind of interesting. The Stream Analytics on Edge, if you're familiar with Stream Analytics in the cloud, it's going to make a lot of sense to you. But if you're not familiar, this could be a little unwieldy. So we're gonna definitely deep dive here to sort of explain like how all this really works underneath the hood, what it is, and even though we're kind of learning backwards, tomorrow we're going to do the Stream Analytics on cloud. But you'll notice there's going to be a lot of crossover between the two.
All right, so we've got our resource. Deployment succeeded. And here's our job. Okay.
So the first thing we're going to do is you have to define these things called inputs and outputs for your job. Now, these are special when you're talking about the edge because they actually correspond to the message routes that are defined in your IoT edge deployment configuration. So what I mean by that is there's a whole section in our deployment template. I think there's a link if you're looking at the module. There's a quick link to that where it says navigate to and it says we will configure these the deployment template. It's right underneath the new Stream Analytics job image. There's the very first sentence. There should be a link there.
Yeah, deployment template route. Let me bump up there we go.
And so these are actually going to correspond to these routes here that are defined here. And what those are doing, we mentioned this before, but I'll restate. This is passing like the output of one job potentially into another job and or forwarding that data up to the IoT hub in the cloud.
So it's just sort of like a pipeline?
Yeah, it's an MQTT topic, essentially, that this is speaking over. And you'll see when it mentions like that syntax into brokered endpoint. So you'll see we have it's basically that first one that's highlighted is saying, take all messages from the DeepStream output. So the output you were literally just showing in your Docker logs. Brokered endpoint is essentially saying inside of a module, I want you to go to the inputs of something called DeepStream input. And because that name is already defined in this configuration as DeepStream input, it is super important that if you're following along here, that you keep these names intact, because they do map from the Stream Analytics job that we're creating in Azure right now down to this configuration that's controlling the device.
And now if they weren't named the same, we would just have to go into that deployment template JSON file that we've edited, I guess, in 2 episodes we've been in there.
Yes, and you would have to sync them up some way. You have to change one or the other. But yes.
I just want to kind of bring this all together because we're sort of looking at it in the browser, but I just wanted to connect it with this. This has been our project, and we've been in here, and then we've gone here and done this whole generate IoT edge deployment manifest, and then come up here to the generated config and done our deployment. I just sort of wanted to connect that back, that in the event that you wanted to call it something different, or maybe had an existing topic you wanted to use for this, that would be the place that you need to make sure that it aligns.
Exactly. And that's a great call out on that. So let's see. So the next thing we'll do, we'll actually define that input, and we're going to use, the reason we're using that name DeepStream input is because, just as Eric showed you, that's what's in our config. So we'll create the input first. If you, over there on the left-hand side, you'll see there's an input section.
Let me bump this up a little.
Under job topology, and we'll add the stream input, and I think it's going to give you one option for Edge Hub, and that just needs to have that exact name, DeepStream input.
DeepStream. We're going to copy it just so that I don't typo it. Okay. JSON, I noticed that it was JSON already, so.
Yes, you can leave those settings default.
Okay.
Now, similarly, we're going to define the output. So this is essentially saying, like, what is, now these are weird. These will make more sense when we show the actual query, but the output allows us to define a aliasable sync in our configuration that we could then forward to, say, IoT Hub or another module. So this one is also defined in the in that same configuration that you're looking at. I believe it's the next line down. So you'll see that DeepStream Analytics to IoT Hub. Now this one's a little special. You'll notice that it says output/summarized detections, and we will elucidate on what that means. And then the other thing to be aware of, how it says into upstream, that $ upstream, it is like a magic alias that essentially means send to the Azure IoT Hub, like forward this to Azure is what that means.
Okay. So is this this is the name we need, right?
The name you'll need is yes. Well, actually,
is that what we name our output?
We're going to create 2 outputs. So one called summarized detections and another called aggregated detections that we don't use explicitly here, but you'll see where we use it in the query.
All right, so output alias, summarized detections. There was a space in there. Okay. Line separated.
And yes, the default options should work.
All right. And then you said we needed another one called aggregate.
Yes, and that's just coming from the GitHub repo instructions. Aggregated. And then yeah, remove the summarize. It's just aggregated detections.
Okay.
Now, these will make sense in just a moment as to why we're creating these.
Why are you saying only alphanumeric character? Oh, because there's a space at the end. Okay.
Now, if you don't create these, when you create the query, it'll be like, what are you talking about? Because we're about to reference these exact outputs in our query.
Okay.
So now what we'll do is navigate to the section that says query. And we're going to actually, yes, you've just done the aggregated detections. You've done the summarized detections.
Yep. All right.
And we're going to go to the query, and you can click that link there, Eric, for the DeepStream Analytics SQL. We're going to actually copy that as our query. Now, this query is gnarly.
Hopefully there's no DBAs on here.
It could, I would love improvements on it. It's it does its job. I'll say that, but it is doing some interesting things. It's doing some regex snatch, but it's doing some heavy lifting, and part of that is just the amazingness of Stream Analytics in general. So I'll give you a quick description of what this even is. So
I guess let's
query, yeah,
go back here and kind of put it up here. All right, here we go.
So yeah, and you can actually copy. I've got a whole section underneath this that explains it. It's that there's that much to it. But given like the quick overview, what Stream Analytics is a way to create time-bound queries against your data rather easily in what is often referred to as a SQL-like syntax. So the big things that you'll notice that stick out in this query is a lot of allusion to something called a timestamp. And that's important. Once you've designated something as a timestamp, you can start to operate on it with the time-based query features and functionalities of Stream Analytics. Those you'll see down like a little bit further below, there's these mentions of tumbling window. What that means, or one way to think about it, is a tumbling window is like let's say this is time 0, and like the window falls at time 15. All of the data included in that section is included in that query, and then it would flip up and go over again, and then that's the next 15 seconds of data that it would do. And what I found with this, you'll notice I have 2 queries that do.
So you're talking about kind of like a rolling window, like this is 30 seconds, then the next 30 seconds.
Yes, exactly. But there's various different types of windows. There's sliding window. I think there's also one that's called what you just said. So we're using the tumbling window, which is essentially saying every 15 seconds activate this query. Now, they're not sequential, so meaning you'll see there's 2 of them that say tumbling window. Every 15 seconds, this whole query gets executed. I know that's confusing to think about. Like if there was one there, you'd be like, okay, I can grok that. Like even when I was writing this, I actually didn't think it would work, but it does. And you'll see why there's multiple queries here. It's kind of the way I broke this down. And I apologize. I never took a database class in college, and that might be showing here. I don't know. Like this could be optimized. I just don't know. I kind of beat this thing with a hammer until it worked.
It's going to depend on the database anyway.
Right. And so we're querying live data that's flowing into that stream. And you can think about that like, if you want to count cars on the highway, like as they're coming in, it's that data while it's in flight, essentially. That's what streaming analytics allows us to operate on. And what it's doing, so you remember when Eric was showing the logs and it was like, like way too much information.
Yeah,
this is going to do that every 15 seconds into a single summarized message.
All right. So I copied the query, and where am I storing this?
So in that little editor window, you can go ahead and paste that in where it's got that select star into alias, etc. And go ahead and save it. And notice those icons on the left right now, how they have like that particular icon next to them, that like blue looking icon. Go ahead and hit refresh after you save. I think they'll change. I think they will. They may not. I thought they would. Maybe I'm thinking of something else, but that's okay. Those actually correspond now. So the outputs can actually be syncs that you reference. So the reason that I defined, or that we chose to define one for both aggregated and summarized, is you might actually want to spin off and do something with the aggregated detections. And you can now. But for our purposes, we're only going to use the summarized detections output. because we've only defined a route with summarized detections. So if you recall when we were looking at that, we never really used aggregated, but we've defined it in such a way that you could if you wanted to. And don't worry, there's a whole section where we're going to explain this. So we don't want to necessarily do this just yet. So let's put it to action and show it filtering some of that data. What's really cool here is this editor that you're in, it actually has a way to upload sample data. So there's like the input preview section, I think you see down there.
Oh, yep, there we go.
And here you can upload sample input. And within the project that you clone to your dev machine, there is a folder that contains some sample data. One is a series of odd edge cases that I just decided to throw in there in case other folks wanted to validate those. And the other is some live running data.
Oh, there we go. So we've got my code directory, and where's our sample data? Under docs?
So that would be in services.
Oh, services.
Stream Analytics, or Azure Stream Analytics, and then Edge. And we could pick, either one. Sample input is the Edge cases, and that one's actually easier to follow. So we could start with that one. The other one is like literally looking at data over like a 30-second window, and it's huge. Like it's massive. So yeah, you can grok this. There's 10 entries here.
Okay.
And so that's literally DeepStream output. So like this is what that would look like. And now because you ran the query, or I'm sorry, that's what it looks like when it's coming in. Now, if you run test query on that, it'll show you what the output of that would be.
Oh, on this test result? Oh, no test query up here?
Yep. So that'll essentially give you a demonstration of like, if this job was to see that input, this is the results it would give you. Oh, someone's joining us. Mr. Chief. Hey there, buddy. Coming to join for work? All right. And so you'll see here that the summary, like if you were to look at this over a 15-second time window, that data is actually saying that it saw 2 total people in the house during the first time epoch. And then the second one, you're looking at the aggregated. If you click over there on the left to summarize detections, it might look a little different. It's approximately the same. And so you'll see there was 2 people detected in the house during the time window, 1 person detected in the yard, and 1 car detected in the yard.
I was gonna say, sweet, it detects people in the car.
Maybe I've seen it detect people on a bike, that which is fun. But yeah, in the car. So this is how you test the queries. This is your how do I say this? Your dev environment. Essentially, it's one way to do it. You can also use Visual Studio. Full-on Visual Studio has a really sweet debugger for building these things out. I want to say I bypassed that for this. That might not have been the best decision. This took days to write, but it might not have been the best decision. And the one thing to point out, if you scroll up to the very top, how we're actually converting this like into flat data. The data that's coming out of DeepStream is not flat at all. In fact, it's like a JSON object that's pipe separated with various different entities. And don't ask me how it works, but the magic of the regex match function there is doing the heavy lifting of essentially lifting out all of the objects and then flattening them in that first stage. But we'll go into more details and when we get into the next section. So once you've done that, you can click to save the query. We've done that. We've tested the query. So now I guess we'll go into more of a deep dive on how this thing actually works. So I've got a bunch of notes that'll help us explain that in the GitHub repo. So we'll follow along there. And I hope the magic of this is clear, like what this is really doing. I mean, it's essentially a super filter that is agnostic to the schema of the data coming into it. So this thing is adaptable to any model you would ever throw at it. So if you throw a model that's detecting, anything, ducks, birds, whatever, this query is going to somehow pull those out and organize them by the uniques or the unique class IDs.
Oh, this is nice because it actually sits here and kind of explains what these things are.
Right. And so that would be like when your DeepStream output was flowing, that is an example of a single capture. And what actually ends up in the IoT hub would look something like that.
Yeah. So, well, I mean, just that we're saying, oh, this is a unique identifier for the object that it was found. Here is the left side of the bounding box. Where in the frame was it found? Here's the top of it. So we kind of, I guess if we look, let me switch over to the capture. Those first two kind of give us this corner right here. And then the next two tell us how wide and how tall the object is.
Yep. And I said that this was the data going to the IoT hub. I mean to say the edge hub running on the Nano device. So that flood of data actually never makes it to the IoT hub. The Stream Analytics job running on the Jetson device filters the data down to the summarized detections that get reported.
So all of the summarizations and things like that are actually taking place on the Nano, and then the aggregated data is being pushed to the cloud.
Correct. Or technically summarized. I guess is what I'm calling. There's a distinction between why, and we'll explain that here. Why I call one aggregated and one summarized. But if you scroll up just a little bit, the first thing to look at is if you look at that first query. The first part of the query aliases the result into something called flattened detections. And the reason I call it that is the data is just not flat. That when it comes through, you're getting that object array, and like it's hard to tell how many of anything is in there. This flattens them into individual entries. So I believe that you would only ever have one entry per entity inside of that object array. And there's a weird trick that I'm doing. I only found this from looking at the data way too long, that I do an additional check to make sure there's not duplicate data being sent. So that's why that matches equals 1 is given there. We actually throw those away if that's higher than 1, because it does happen where you can sometimes get, like DeepStream might duplicate a result, as in it'll give you the same object detections and the same exact timestamp one after another. That ensures that those don't get reported.
Gotcha.
There's also another weird edge case you see there too, where it's like filtering out. You'll notice the familiar Unix start time epoch timestamp. If you scroll up there to the first one, yeah, that 1970-01-000. The reason for that is sometimes I don't see this anymore, but at least not in my current configuration for my cameras. But I did find that depending on how your cameras were set up, if they were experiencing like lag and they would just die and throw an exception in the middle of DeepStream creating a message, the timestamp would actually never get hydrated, and so you would end up with the start Unix timestamp. So you want to throw those away as well. So you'll notice there's a where that says those timestamps aren't equal to 1970.
Oh, that's interesting. And I guess that's well, I'm not as familiar with the RTSP protocol, but I know in RTMP, the headers and things like that can actually change. There's a different amount of information in different message types. So it could send you a message type, I forget what they are, but let's call 1, and a 1 gives you like an iframe, and it gives you the timestamp and all of these things. Well, message type 2 might not include the timestamp or something, right? It's like, just assume that it's the next frame. And they did all of this to make the protocol more efficient. So it's really interesting, and it's been a while. I'll have to pull up something that walks through it. But yeah, there's, I don't know, 3 or 4 different bits of information that kind of get dropped based on the specific message type. And it basically is just implicit Like, if I didn't send that to you, assume it's the same as the last time, or that it's the next frame, or things like that. So that could be a reason for this, is that maybe if you don't have the initial connection, you don't have the prior information to be able to implicitly change that. But I'm not as familiar with RTSP.
Totally. And I what I found, it only occurred when like there was an exception. So like, as it's trying to create the message, it's probably newing up all those fields. Like, start with, new timestamp or whatever, which gets times 70 or whatever. Exception gets thrown, and then, oh wait, we never updated the timestamp, but I sent a message anyway. And so you end up, but it's also interesting to note there. There is a field now, or a parameter that you can set in your DeepStream config that's called attach NTP as timestamp, and that will that actually alleviates this. I don't think it solves the issue when you encounter an exception, but it will alleviate it to the point that if your RTSP camera, like doesn't include the timestamp in the in its headers, as you were just saying, it'll actually provide them from the NTP time from the host system that it's running on.
Okay.
And that's a new feature in DeepStream 5. It's called sys NTP timestamp. It's commented out, I believe, in the default DeepStream config if you wanted to mess around with that. But that's part one. And while you're here, so now we're going to look at the second piece, which is the aggregated detections. So that essentially throws out any of those duplicates, and then adds them into a table. Now, this one is interesting because it's going to have way more data than the summarized detections. And the reason why, there's a subtle difference in the summarized detections. If you scroll a little bit down, you'll see what it is. So this counts that actually counts how many detections occurred over the 15 seconds. And then what the next one does is it actually smooths it. So it floors the average of them. And so what I mean by that is it looks at what was the average number in that 15-second period of all the people you say. Let's just use that as an example. And let's say it saw 4 people. Well, if the average of that is a different value, the average maybe comes out to 2.5, it'll floor that down to 2, and it will report, you know what, I'm pretty sure I only saw 2 people at this time. So it's kind of a smoothing function that takes care of, sometimes you'll see overlapping bounding boxes and things like that. I found that this was a nice way to smooth that data and get it pretty darn accurate. I'm not going to say it's perfect, but it's pretty close.
Well, and I guess you have some things too, like dropped frames or things like that, where movement may take place and it's calculating based on a ghosted image too. So you've got kind of like where the car was plus where the car is now, and it thinks that's 2, when the reality of it is that it was only 1.
Right. So you would think, so let's say that happened. That's a great example. So like I detected 1 car, then you have some sort of RTSP stream messes up and you see 2 cars, but there was really only 1 car. And so now you get, how do I do this? Okay. So you get, I need 3 hands to show you so it's like there's 1, then there's 2, and then there's 1, right? But the 2 was erroneous. So what the smoothing function will do is it'll say, you know what, the average was, so if we had 1 plus 2 would be 4/3, and so that would be a 1.75 would be that result. That would be the aggregated result, 1.75. But then if you floor that, you get that down to the accurate result, which is there was in fact 1 car. Sorry, I hope that made sense. Is there a better way to explain that, Eric? I'm asking for help.
No, no, it makes sense, right? Because you're going to have glitches, you're going to have things like that. So you're going to get a random frame of video that may not have an accurate image. You see it all the time in gaming, even, Chrome or Edge sometimes is like leaving an artifact of the window on the screen for like a few frames when you switch to another program, and it's not actually there. It's just leftover artifact due to just the efficiencies of how drawing on screens and things like that take place. So yeah, it makes perfect sense why you would want to kind of smooth that out to ensure that any leftover artifacts for a frame or 2 don't count. And I mean, could you imagine if that was triggering some kind of alert right?
Right.
And let's
Right.
just say the video kind of got choppy and it's telling you there was, 27 people outside your house.
So great point. That's actually how I discovered that edge case is I was plotting this in the Power BI, which we'll do tomorrow. And I was looking at the graph, I let it run for 24 hours. I'm like, when the heck were 30 people outside of my house? And so I actually went back and captured the data and I looked at it really close. And it was exactly as you said. It was an artifact had somehow produced some sort of result where it was doing that. And simply by doing a smoothing function, where it's like, you can say, well, did you see 30 people for 15 seconds? Because if you did that, then I'll accept it. But if you didn't, then I'm going to take an average of what I saw and then floor that. And then you get down to 1.
And now it was 15 seconds. Was there a particular reason for that number, or is that just you like the number 15?
So I started off with 60 seconds, and I thought that was like just not enough. I chose 15 to keep things in bounds. Where remember way back in Module 2, we were talking about the limitations of the free tier IoT hub. This gets you a lot of data and could have you running multiple devices and still not hit the limit. I don't remember what that number was that we came up with, but this is 4 times per minute, right? This is 15 seconds. So that's 4 times per minute. And there's how many minutes in a day? There is 1,440. So it's it's going to send because there might be times when it's seeing nothing. So if you average that out, it's approximately per device. It would send 4,000 messages in a day, give or take.
Okay, so you were doing the math kind of to keep you in a particular tier.
To keep you in a place where someone could use a free tier and have 2 devices, both running the job and not exceed the free tier limit.
What I find amusing about this whole smoothing function thing is that this was written by somebody who does electrical engineering. It's basically debounce, right? Like,
it's exactly that.
There's some jitter where when you press a button, you get kind of like an on-off bounce. How do we do that? We just sort of average around it and try to guess how many times it was actually pressed.
Well, and the cool thing too is like, look at this syntax. That's I was trying to hint at this earlier. I hope I'm selling the beauty of what Stream Analytics is. I mean, to solve any sort of problem where it's like time bound, it's just the most perfect syntax. I don't have to like write a for loop, like X, seconds, look through this thing, keep track of a variable or whatever. No, just call tumbling window and it takes care of it all for you. So I just love that. Yeah, it's a beautiful syntax.
So now, do we already have the data being pushed in here, or are there changes we have to make to get that there?
Small things. So yes, that is the next thing we'll do. We're actually going. So this is fun though. The way that these jobs actually exist and get down to your device is they get published into an attached Azure Blob storage. That when the DeepStream Analytics, which is technically an IoT on Edge Stream Analytics module, I'm saying a lot, sorry. When that job starts, what it does, there's a configuration in our deployment. So hopefully this is still keeping track. It wakes up and it talks to that endpoint where your job sits in blob storage, downloads it, extracts the zip file, and then it executes this query that we have just written here locally on the device somehow.
Magic.
Well, I say magic because I'm like, I don't know what the actual Stream Analytics runtime is. Like, I don't think that piece is open. I don't know what it in fact is underneath the hood. Maybe if you dig deep, you could figure it out. But somehow this syntax actually runs locally. There's some sort of runtime that is effectively Stream Analytics running locally on your device.
Oh, that's pretty awesome. So yeah,
it's no joke. Yeah, so there's a lot of heavy lifting that thing is doing.
No, I just like it because with so much of these edge devices, you have to worry about connectivity, right? Like you may have intermittent connectivity, so the idea that you're not having to have a really solid connection to like let's take like a shipping boat, right? Like they've got a small satellite uplink, right? So they're going to want to do stuff and collect all these metrics and do all of this stuff, and then maybe push it up when they're at port or something, right?
Right.
So yeah, this is super cool that you can build all this stuff out as if you're using a cloud service and then just have it kind of run on the edge on your edge device itself.
So that was a great example. And to your point, and in fact, what it is doing, you're correct. This job, so obviously the DeepStream workload doesn't need internet to work. It just needs a GPU and effectively, an environment capable of running the DeepStream job. The stream analytics is in the same way. It's a containerized workload, so it's producing those messages, but it goes a step further. The messages that it's outputting to IoT Hub, if I was to unplug my internet, it will still locally cache those messages. And just as you said, when the boat goes to port, those filtered messages will then arrive to the upstream up to the Azure IoT Hub. So that's what I'm saying. It's fantastic. It's much more than just doing the query. It's the whole thing working in concert with each other is kind of the beauty of it all, as you elegantly explained there.
All right. So how do we get it there?
So the next step, and this is in the instructions. I can guide you. So we will go to storage account settings. Which should be.
Let's find our storage account
Under configure.
I'm gonna go to our resource group and go.
Oh no! Go back to the job. Sorry. Yeah.
Oh. Storage account settings on the job. There we go.
Yeah. And so click add storage account. And this is actually going to create a new one for you. Or you could, actually you can reuse one. It'd be a little weird to use that container. So yeah, we'll create a new one.
And call this what? DeepStream Analytics, maybe?
Yep. And that name, I don't think you're super bound to. Just FYI, I don't think. Oh, and so storage accounts, only lowercase letters. That always.
Wait, only lowercase?
Yeah, it always gets me.
All right, have it your way, Azure.
I love it. And then what you'll do once you save that, I believe that now you can light up the publish option. So right below that, there's a publish section, and let's see if it'll let you do that. Yeah, hit yes. Now there's a cheap way that you could get your job working in your config. When this finishes, it's going to spit out a SAS URL, and you could literally just replace the URL in the config and go about your day. It'll then pull from your blob storage. But that's not the right way to do it, or like the best way to do it. So I'm going to show you a better way.
Okay.
Which is going to involve a little bit of surgery or some slap chop. So your SAS URL is there, and if you were to look in the DeepStream configuration, or the IoT Edge deployment, you will see there is a SAS URL that looks like that already, and you could just flat out replace it. But we're not going to do that. We're going to do it the clean way because there's more to it. This will actually allow you to keep it in sync with your instance. If you just provide the SAS URL, it'll just blindly always download that. And if that thing ever expires or gets deleted, new jobs that don't already have the zip downloaded will fail to run the Stream Analytics job. So we want to do this the right way.
Okay.
So we'll open up your VS Code instance again and go to the deployment template in question. And in the documentation, I show exactly where you want to highlight. We're going to do some surgery here. I'll just point it out to you here, Eric. It's the DeepStream Analytics module. This is going to seem weird. We're actually going to delete it from the config.
Okay, we're going to delete the entire thing.
And the reason why is there's a magic plugin that there's no way to update an existing one. We need to. The tooling is not mature enough for that yet, but it can add them brand new. So if it already exists, it won't add it. So we have to delete it so we can add it fresh again.
Oh, we're going to delete the whole thing. So we are not actually replacing the configuration. We're going to delete the whole thing. Okay.
Just for that module though.
Right. So we left the camera tagging module. We only deleted DeepStream SDK.
No, wrong one. Sorry. Yeah, be careful. Be careful with that. Control Z that. Sorry.
All right.
We want to do the DeepStream Analytics module. Sorry.
Ah.
Maybe that's a good mistake though. If anyone's watching here, make sure you get the right one here, and get the comma because it happens to be the last one in the. So you'll want to get the comma on line 187.
Sorry.
Oh, you're using Vim keys, aren't you?
I am using Vim keys.
Oh, you're too cool. Can the Vim key also get the comma though? Is it smart enough for that?
Well, I mean, it just depends on what you do, right? So in this particular case, I'm inside curly braces, so I just do a DI for delete inner curly brace, and I delete everything that's inside of there.
So. You're too cool. Now, if you're a noob like me, I just highlight what I want to go. So hopefully you can follow along with the picture and the dots. Anyone who wants to.
Once you sort of learn the sort of, there's the multiplier, which is the number of times to do the thing. Then there's the command, which is D, right, for delete. And then there's sort of the modifier that explains what am I deleting. So DI is delete inner what, curly brace. I could have said DW for delete word, DD for just quickly delete a line. So once you sort of memorize that, it becomes sort of easy because then those same modifiers apply to other things, right? So if I had done inside of here, I did a CI for change inner, then that does the same thing as delete, but puts me ready to type. So once you sort of pick up those commands and the modifiers, then you can kind of combine them to do what it is you want to do.
I just think it's so epic because you get in this mode where you have to think like a program. So
once you do it, it's so efficient. It drives me nuts, right? Like, so here, if I just wanted to change that 1.0, right? F to the dot, right? I just jumped in there, CI double quotes, right? And then I can change inside of the quotes, right?
You are showing off, man. I'm envious of that skill. That is so cool. I'm sure a ton of the viewers out there are like, yeah, we all use Vim, DeCarlo. What the hell? So, yeah, I'm probably the odd man out here. So once we've got that out, now we can bring up the command palette again with Control Shift P. If there's one chord you ever want to remember for VS Code, it is Control Shift P. And we're going to look for Azure IoT Edge. Azure space IoT Edge, I should say, space IoT space Edge, colon, add IoT Edge module, and make absolutely sure you choose the IoT Hub deployment, not the IoT Central one.
Yep, okay.
And for those of y'all paying attention, yes, this project can support IoT Central. I don't know when the video will get made for that. It's tough. So the Azure Stream Analytics, we want to go ahead and create a new Azure Stream Analytics.
And we're calling it the same thing?
And name it exactly the same thing. It's super important that you name it DeepStream Analytics. Capital D, capital S, capital A, DeepStream Analytics. I realized that wasn't a very accurate description. There's many A's, S's. But yes, now see, it's smart. It knows that you have a job, right? That DeepStream Analytics job. So select that one.
And now this is because I have the Azure plugin.
Right.
There's some stuff I've done, right? So down here, you can actually see that I'm logged into the Azure plugin as my Microsoft account, just in case you try to do that and it's like, what you talking about?
Now, I've seen this thing fail. And when it does, just close VS Code and try it again. Yours worked, which is awesome. And see, it says deployment template JSON updated. Now, it just did some stuff that's a little bit dastardly. Like this is some feedback for the tooling team. It actually changed your routes. So it put the DeepStream Analytics back in exactly the way it was, with one exception. It's going to pull that particular tag, which they don't define a manifest for. So we're running on ARM. If you try to pull that image URL that it just created for you, that will fail on an ARM device.
The Azure IoT Edge one?
Yes, sir. So the first thing you're going to want to change is, and this is in the documentation, you'll want to change that to instead to have Azure 1.0.6, then you're going to do dash Linux dash ARM32 v7. Now, for those of y'all paying a lot of attention, you might be like, well, aren't we using an ARM64 device? Yes, ARM32 containers can run on ARM64, and we don't have an ARM64 flavor of this. And in fact, when I figured this out, I think I had to query the repo to find out that this tag existed. So I don't even know if we publicize that there's an ARM build, but there's totally a publicly available one for the that is for the Stream Analytics on Edge. So you want to make sure you fix that. And then, yeah, that's some good feedback. I'm taking notes because I might have to send some emails tomorrow about this. It's understandable. But this is real talk. It changed some other stuff too. It changed your routes, and that's just dastardly because it didn't tell you. So if you go back down to go up a little bit, sorry, down a little bit to the routes, they're a little bit lower. Right there. So your DeepStream Analytics to IoT Hub is not the same. Remember before it was / summarized detections. Now it's changed it to /star. So you see that output /star.
Oh, yeah.
What that would do, if you were to accidentally put this in here, you'd get duplicate messages because remember we defined an output sync called summarized detections, and we also defined one called aggregated detections.
Oh, right. Yeah.
That syntax will send both of them. And we don't want that. We want to modify that to just be summarized detections. I think that's the only part you change. Yeah. And then into upstream. That looks right. And it changed some other stuff too. Now this stuff actually did, I did have some foresight. I reached out to the dev team on this before I wrote this doc. Because it does add some additional things, and it's not really clear in the documentation what those do. But I got the answer from them directly, and that is in our documentation. So, taking notes here. I got a job tomorrow. So it actually created a whole slew of fields down there. You'll see that, like right at the very end. Those are the desired properties for that module, and what that essentially means is the default configuration for that module whenever it spins up. So it's going to set some properties that control some things inside of its source code. And those are explained here. So the first one is the ASA job info. So remember I told you earlier, you could straight up just copy that URL that you just saw in Azure and replace the ASA job info that was there before. You can even see the diff. The remaining three things were not there before. They're only there when you add the module using the tooling as you just did. And so the ASA job info is the URL to where the published job exists as a zip package in blob storage. The job resource ID is the resource ID of the job you want to use. So it's used by the module. It'll actually look up to see if your job is updated after initial deployment. And if it has, it can actually be smart enough to pull it down. And when it pulls it down, it will update the ASA job E tag, which is the hash of the currently deployed job, as well as update the published timestamp there. So because we use the tooling now, because it has that ASA job resource ID, the module is now smart enough to pick up. If you were to update the query, any devices that have outbound connection to Azure will see that, and it will update the job down at the edge.
Oh, perfect.
So I was, and trust me, I was half tempted to just like when I was writing the docs, I was like, I could just say copy paste and get this over with, but this is the right way to do it. And now it should be clear why I was kind of harping on that a little bit earlier. So now the last thing you need to do, you're good at this, this one. We've done this so many times now. We got to redeploy with our new config.
All right, so we go to our deployment template, we generate our deployment manifest, then we go find it in config, and we create for single device, and deploy to the Jetson Nano.
There's got to be a shortcut for that. We do that so often.
Yeah, there should be one. I would say just on here, right? Well,
Yeah, or like deploy the last thing or so.
well, we
Yeah.
got build and push, build and run on the simulator. So why isn't there like a build and run for whatever? Because
Those are a bit different. I mean, I can kind of see why. I'm just thinking like ways to speed up the dev loop. And this project is weird because it has two deployments. We have one for IoT Central and one for IoT Hub. And because of that, um, it doesn't change anything. The tooling is the same whether you have one or two, but it is, just keep that in mind that this solution is a little bit odd. You always have to keep track of which one you actually want to deploy because there's multiple deployment templates.
gotcha.
So now that you've deployed that, just double check that the job restarted and that things look healthy on the Jetson device. It's not a bad idea. Let's bring that up and we'll do a Docker logs on DeepStream Analytics, just to make sure. You want to make sure that thing's up and running.
So yeah, I mean, we've got it running here. So I don't know whether I saw it restart though.
Oh, so that's the DeepStream workload. That one wouldn't start, but we want to open the DeepStream Analytics one. And I don't think we've opened that one yet. So it's kind of fun.
Is it just called DeepStream Analytics? I think.
Yes.
No, NVIDIA. There we go.
And so see these messages here where it's saying like ASA register. I think that's it trying to tell you it updated the job. It also, that looks like DeepStream output. Scroll up a little bit. Let's just make sure this thing's kosher. Yeah, so there you can see once you made that new configuration, here it is, initializing the ASA engine, reading your new job, dropping it into a new directory. If you scroll up a little bit higher, I think we can actually see the URL, and you'll notice it has that publish date of 6/18. That's yours. That is your job.
Oh yeah, and you can see it kind of downloading the package.
And that's how it works. That's how it goes from cloud to device.
Nice. All right.
So that was cool. I think that came together rather nicely. So now we've got our data coming. We've got this with our own device. Let's start seeing the data in time series insights. So now we can actually visualize this data using one service in Azure. And I already fixed that missing image. You're going to see a missing image in the documentation. I fixed that. I just didn't push it yet. But yeah, we'll go to the next step here, which is going to be module 4.5. So, and this TSI stuff, I will say it is more than just the dashboard. In fact, there are more things that tie these two services together than what we're going to touch on today. In fact, I think I hit on it just a little bit in the earlier module. Like you now have enough knowledge out there to know how to change the tumbling window, right? Like, if you want to change that to do every 5 seconds, you know that. There's also a special syntax in time series insights where you can denote certain results as anomalies, and it will actually render different. So you can see that time series insights, how it's got that graph, and you can see like certain things look a different way. Mm-hmm. I don't know if it's actually showing there. You can actually denote that something is in fact an anomaly by detecting it with the Stream Analytics query on the device. So I just want to point out there's more to that links the two. We don't have an example of it in this workshop or module, but there is a special syntax that you can do to designate your result as an anomaly. And that's interesting because you can handle it locally, and you can also see it later on when you actually see our dashboard go up. You can see it there. I just want to make sure I mention that.
Oh, that's pretty cool.
These things are married. Like there's queries, the query syntax and the service have special things that can be done. So we'll go ahead and spin up the TSI service. And this isn't too hard to do, but you'll see when we set this up, one of the things that's super important to pay attention to is it's going to require that we set a partition key for the data, and that is a one-shot, one-kill operation. And so you're going to see that right here. So the first thing we'll do is give it a name, and I do not think the name matters here at all. The name does not matter in this service. And you want to set pay-as-you-go. And the reason why pay-as-you-go is cheaper than S1. You saw S1 was like $150 a month. The entry for this service is a little bit high. So totally get it if we've lost people who don't want to do this step. Totally get it. But pay-as-you-go will limit this. And you'll want to check the pricing. I didn't include it in the documentation because it changes.
And now that might be something interesting to look at some point too. At what point can we kind of inject ourselves to like scrape this data and send it to an open source time series database or something like that? Maybe you're already running a time series database and you would prefer it there.
The one way to do that actually would be generate a module that communicates with service XYZ. So build an IoT Edge module, deploy it as a container. Maybe it sends to whatever your time series service is, and throw the output from that SAS job into it. And then you're absolutely right. You could mirror the same result we're going to get here to other services.
And so far, all of this has been generating JSON, so you should be able to kind of take it and do what you want with it. If you don't like clicking buttons and just having it magically work.
Exactly. And you can actually change the format too. Remember, we actually defined those outputs as JSON earlier. Right. You could actually change that too. So if you want to use Avro or something else, that's a good point. So yeah, I mean, Stream Analytics is kind of the fulcrum, if you will, that can allow you to get into other areas. It is the super filter. And the cost for that, I should have mentioned that earlier. The Stream Analytics job on the Edge is $1 per device per month, I want to say. So every 30 days, however many devices are running that job is $1, which isn't bad. So this property name that you see here, so that time series ID is very important. It is like the partition key essentially for your data.
That's what this property name is?
Yes.
Okay.
Yes. And scroll up just a little bit. I want to make sure we're using the right thing. Yeah. Okay. Now, through trial and error, I found that the best results that I got with the data that's in the shape that we're getting from our Stream Analytics job, I found it was best partitioned with 2 keys. Partially because of how it will end up as a visualization in time series insights, like how it will model it. Mm-hmm. And also there's some logic behind it. So what we're going to use is the sensor ID as the first property. And this goes all the way back to the very first thing we did at the beginning of this video, where we remember when we updated the it's sensor
capital I ID. Yeah.
Now this first has a tie-in to when you updated your message conv in the very beginning. Remember when we updated it so your output changed from camera 0 to office and street? So yeah, make absolutely sure that it's called sensor ID. And the reason for that is our Stream Analytics query produces a result that literally contains something called sensor ID in it. So that's why we want to partition on that. And the second thing we're going to partition on is something called IoT Hub Connection Device ID. Now that is a reserved entity that is produced by all IoT Hub devices. And in fact, if you click on the I, it'll tell you more info about that. And you want to make sure that one is spelled exactly correct. If you do want to get a quick copy paste, the I that's right next to property name will tell you more about it and bring you to some more info that explains it. So if you click on learn more, I mean, it like literally this time series ID is so important. And I'm like stop the presses here.
Now I'm going to copy and paste that just to be sure.
Now, so what these things are, and I think you could actually flop them around too. You could do IoT Hub Sensor, or, whichever one. Now, can you think of why I might have chosen this before we get there, Eric? Like why I would choose to do a dual partition for the time series ID?
Because you're querying it by 2 different things.
Yeah. So think about it like this. Like intuitively, you might think, let's just use the IoT Hub Connection Device ID. Then I can see, what data is being produced by which device, like device X, device Y, device Z. So, Jetson 1, Jetson 2, Jetson 3. The problem is the Jetson device actually looks at more than one camera.
Oh, right. Yeah. So one of them, you're Gotcha. Like
So
show me all of the data that this one device has sent versus show me all of the data for this very specific camera.
right. And so now we can partition the data by sensor ID. Like if I was to choose just one key, I would probably go with sensor ID. But having both, I can now get down to what device was talking to what sensor ID and partition it that way. And the reason that makes sense is like, when we're using names for sensor IDs like office and yard and stuff like that, you might have more than one device, and they might also have a sensor ID called office, yard, pool, whatever the heck. This, by having them separate, I overthought it. I overthought the edge case and realized I think using two keys here make sure you never stomp on the data of another device or another sensor.
Right. So you're actually, so is this creating, so this isn't querying it by two things. This is actually creating the partition key based on a hash of these two values together.
Yes, and the other reason for this too, I think it speeds up the query. I've not tested that, but I think having, just like we would see in a non-relational database, having multiple keys always like allows you to zero in on the data a little bit better. So that's the logic there. This is so important. I know we only entered 2 fields here, but like this is so important. If you don't get it right, you got to destroy the time series insights instance and start over again.
All right, so it looks like we have to create a cold storage account too.
Yes, it is a little bit of a bummer that you can't reuse that existing one again here. It is going to ask you to create. So you can call this, that works. Yeah. Well, don't call it cold though, because it can actually go both cold and warm. Yeah.
All right, so.
And maybe call it store. I always put store at the end of my things, just, there's actually somewhere, I don't remember where it is, there is a naming best practices for Azure. It's in the official docs, and they say to prepend everything with ST, but I don't know that, like, I didn't subscribe to that. And they said prepend it because like I have a habit. What I do is I prepend everything with the resource group. So like, if the resource group is called accelerated edge, I would call it accelerated edge -thing, or accelerated edge store, or something like that, or storage.
Gotcha.
So yeah, I mean, putting it as a suffix would make a little more sense, but you can see where that gets weird.
Yeah. Do we need a warm store?
We're going to enable it, and this is one of those things. Again, you don't need it. So if you want to save money on your deployment, you can actually disable that. We will enable warm store, and we'll keep it up for 7 days by default.
And do we need to set an event source, or are we just creating? Okay.
Yes. So this is what's going to wire it up. So this software as a service that is time series insights. To wire that up to the IoT hub, we have to create an event source. And the way I name these usually is, DeepStream Analytics IoT hub event source or something like that. It's not a bad idea. And yeah, you should be able to select existing and of course choose the IoT hub that you've been doing for the entirety of this content. The consumer group. Now this, my friend, is really important.
What are we setting for our access policy? Service?
You can use IoT hub owner here.
Okay.
It won't hurt you because this gets stored in Azure. So for the IoT hub consumer group, we're going to create a new one, and this is going to resurface tomorrow, by the way, on our next module. Call this thing TSI and add a new one. And what this is the IoT hub uses consumer groups for, in just a moment, we'll fill in the property name for timestamp in just a sec. The consumer group is, by default, your IoT hub, each consumer group can allow five readers. And so you want to create new ones essentially every time that you're creating a new service. That's a good practice. Because if you don't, and you exhaust those 5 readers, and like for whatever reason, your requirements now require a 6th thing to read from the service, you can't use that same consumer group anymore.
Now, does this work in a similar manner as like Kafka does with the consumer group? Okay, so then the other thing you would get from this is that when we talk about databases, time series databases and things like that, or messaging systems, the consumer group also tracks where in the log that particular consumer left off. So if it ever gets disconnected, it picks back up where it left off. So it would allow two different services to consume the data. So, if you were pumping data into, or like Kafka was like where the data came in, but then you had something consuming from Kafka to put it in both Postgres and something else like time series, then it would be that you would want them in individual consumer groups.
Right. I guess like one of the ways I always try to think about it like simply, because you're right. If you can get into it, and it is in fact under the hood, it is Kafka. And if you're familiar with that, then the answer is probably clear as day to you. For someone like myself, I always think about it like it's not, you can't have infinite people reading from the IoT hub. You have to designate who can read, and that is because, just as you said, there's a it tells you like, hey, I'm at message 0, or I'm at message 10, or I'm at message 100, depending on who you are when you're reading it. And if you don't designate a unique consumer group per service, then your services could end up re-indexing where you were last left off, as you just said, and then you would not be getting the data you would expect.
Yeah, if you had two separate, if you had two separate services leveraging the same consumer group, if your Postgres service consumed a message, then your notification system that's meant to see every message would not see that message. And
it's literally the problem the Ghostbusters had. Don't cross the streams is literally what it is. Don't do that, because if you do, then you don't know which one was reading from which. I think if you hover over the eye, that one will tell us, maybe might give us a better example there. The number of members is limited to 5. Use a separate I can't read that.
Yeah, that would probably, it doesn't mention anything about where in the log or things like that. That would probably be an area that should probably be better documented, just so there's an understanding that is,
Because yeah, I'm feeling like I'm having a difficulty putting it into words too. I know what it is because I've seen what happens when you do it wrong. That's basically what I'm drawing from. But yes, make sure you create a new one. That's important. And for the property name, if you notice the output of our Stream Analytics query, it does create something called a timestamp, and it actually uses the @ sign in front of it. So it's at lowercase timestamp is what we're going to enter in for that value. If you don't do that, it will create a default one based on the message and queued time of the message, which is approximately the same thing. Well, not necessarily. Not if you're in that situation where you're a boat that pulled up to a dock. The message may be enqueued at a later time than when it was actually seen.
You may get 3 weeks of data all at once.
And that would probably knock off a whole bunch of alarms or anomaly detections. So yes, that is very important. So once you've got all that clear, I mean, I'm sure all the database administrators and stuff on here are like, DeCarlo, we know this. We always get this right. Problem is, folks like me who didn't even take the course on it in college is like,
I don't know. I've been doing this enough years and I still make the same dumb mistakes. So I at least hope I'm not alone in that.
I learned databases by PHP MyAdmin. Don't kill me for that. That's where I learned.
I wonder if that's still used.
To some extent, yeah.
All right. Wait, now I lost what we were doing.
Sebastian of Security. This thing's funny. It does this to me all the time. You did create a new thing. It is in that resource. It's just going to take a little bit to show up.
Oh, and it looks like I've been bouncing between East US and East US 2 out of confusion.
Oh, that's okay. That was only with the...
There we go. Here's that time series insight.
Was with the Stream That's okay. That's actually not going to cause a hit because it was your Stream Analytics on Edge job. So that's not going to take a hit because that runs locally, and your cognitive services job too, which again is completely outside of this. So those won't hurt you. So now if you click on that time series insights explorer thing over there on the right, the big blue URL under SKU.
Wait.
If you click on that, that'll take you to the instance. And we're going to fast track create something that can model this data. So what's cool about this thing, it'll let you share data. There's all sorts of awesome stuff. Bummer. So this is a good example of why we changed the message conv at the beginning. But it seems like we still have some camera 0 results in there. I guess that's because
we just connected online recently, and it sent data that was in a local log.
It's in the IoT Hub historical data. Oh, what a bummer. That's okay. That's okay. But now you see why you want to have that set up before. We did that though. We did set this up beforehand. It should not have that result in there, but that's okay. So you will have a little bit of duplication here, Eric, but it'll go away after 7 to 30 days. I can't remember which one.
That's all right.
Once it's flushed from the time series insight storage. So the next thing we'll do, and sorry, folks, for getting ahead there. That was the thing we wanted to avoid. We will go to, over there on the left side, there's a thing called model. It's really unobvious, but if you hover over it.
There we go.
And what we're going to do here is a few things. We're going to actually import some predefined models. Now, if you were building something from scratch, this is the whole bread and, well, what's the metaphor I want to use here? This is how you make this thing work. You gotta know your data schema for this. That's what I'm saying. The data folks on here are probably like, yeah, that's normal. It took me a while to figure this out. So if you go over there to the far right, where it says types, we're going to start there and we're going to define a type. And this will allow us to actually visualize our data in a specific way once it renders in the time series insights dashboard. And what we're going to do here, we're going to import a type that already exists that I named object detection type. What's cool is if you do define types, you can import them, you can export them, so you can store them as part of your source code and things like that. And this will be in the source code that you've cloned down your machine in the services/time series insights folder. And it should be under types. Yep. And we'll import that. And the only way this will work is if your Stream Analytics query was exactly the same. Because remember, there's a tight coupling here between these two services, at least in the model. There's things you can do to change that, but get you out of it. So go ahead and expand that object detection type. It's kind of interesting how this works. So you'll notice it does three things. There's one called detections, there's one called person, and there's one called vehicle. So detections is like an all up. Like that's, if I detected a keyboard, if I detected a bottle, if I detected a bird, a dog, whatever, those all get caught up in there. And you can see why. If you click on the edit button there, that will show you the query, which I don't want to be wrong about this, but I'm almost positive it's DAX query, but I could, maybe it's something else. And this actually sets up a query against your data that it can then model behind. So if you see here, notice the way that I define that. There's a thing called where it keeps each of my categories in there. So if you wanted to modify this to include or exclude things from the detections reporting, you would do that here. Does that make sense? And you see how it, I apologize, I can't see your full screen. There's something on there's a label and there's the value.
Right.
Label is what is used by time series insights. Value is what must be present in the data schema that's coming into time series insights.
Gotcha. So if I find this value, it's going to be displayed under this label.
Yes, and this is a great time. The vehicle one is a great example of this. You can comma separate these. So vehicle, you could put car, comma truck here. And that would aggregate both things that are detected as a car and a truck as a vehicle.
Okay.
Bicycle is a bicycle, roadside is a road sign, etc. But add entities here as needed. This is where you would make some modifications. And the default category is called none. So that means if something doesn't map to any of those that we explicitly defined, they just get tallied up into the none category. So say you saw a dog, because that's not here, that would go in the none category.
Okay.
And if you go, I think if you go down to the bottom, there might be something else in that query. I don't recall. This was a while since I looked at it. I blew away my time series insights before this call, precisely because I had bad data in it. So if you go ahead and click the edit again for detections, and scroll all the way down to advanced, and there's something in there. I can't read it. It says something not equal null.
There's a filter looking for event.object.string not equal to null.
Okay, yeah. So that is, so long as don't. That's to keep it from reporting things that like are not object detections and throwing those into the none category, if that makes sense.
Yeah.
Now, the person and vehicle are a little more interesting. So if you click into those, similarly, I shouldn't say interesting. They're fine grained. These will only report. So this will allow you to plot like were people detected. So instead of a catch-all for like was objects detected, this is were people detected. And you'll see the query is a little bit different here. And it looks at the max value there. There's a reason for that, because we want it to report the maximum versus like each discrete entry that it's seeing. I don't know that that necessarily matters because we're filtering the data, but that should make sense. And then you'll see down there at the very bottom how it is that I'm zeroing in on person is because of that query right there that you see. I know it's weird. Y'all can see that clear, but it's weird on my screen. I actually can't see it. So it's an event object equals person, and that's how you zero in on it. And that's it.
Okay.
And vehicle will be the same thing.
Okay.
That's better. That's better. Nice.
And then I noticed in uploading this that it said that there was also a hierarchy thing in there. Is that also something we are uploading?
Yes, we're going to do that. So let me explain why. Give you an example why. Go back to the dashboard of time series insights real quick. Notice how your data is like laid out currently. See how it says like to organize your time series instances into a hierarchy, create a model. It's giving you a bit of a clue here. It's saying like, dude, I don't want to look at something called camera 0 Jetson. I want it to be like Eric's house, right? That's what a hierarchy is. It's a logical organization of the entities that you're modeling in time series insights.
Gotcha.
So we'll go ahead and create the hierarchy next.
So in this particular case, we could organize it based on location. So we could say office, camera 1, camera 2 underneath it or something, street, camera 1, camera 2. Or we could do it based on device where we put Jetson Nano and then the cameras it's responsible for.
All of that. Yes, exactly. Whatever you want to do. Now, the example one that I threw up here is more like base of operation or your home. Like I put my like Paul's house there. So I think we'll probably use like Eric's house here. So when you load this one in and you look at it, all it does is it creates a thing called location and it has an instance field called address. That's it. Okay. Now, that's going to essentially do like a decorator pattern on your instances now. We'll now have a field called address that you can use to sort them by. So we'll now go to instances and like pick one of these like Street Jetson Nano, I guess. And if you click on the hierarchy, select locations. And here, you can actually go ahead and for the name or for the address, you could put Eric's house there. You could put your actual address here, of course, if you're going to production, but you just put Eric's house.
And just dox myself.
Like I did. I put my address in the video. Feel free to send me good things if anybody noticed that. You have my address. It's in this repo. Look for it.
You know, people are people watching these types of things are really smart. Finding somebody's address is not super complicated.
Yeah, I mean, I figure if you want to pay the $5 to, you know, find
To
find
skip trace
XYZ or
Paul.
whatever.com, yeah. You can get me if you want. So I did it because of my reporting. I wanted it to look like that. So yeah, you can change that for all of those.
Can we delete these and then they don't show up anymore?
Dude, I never thought about that. Wow.
Let's.
No, because there's ingested events. You can't do it until the events don't exist anymore.
It let me delete the other one, but okay.
Well, because there was no events for that one.
So okay.
That one it will let you delete 7 to 30 days from now.
Gotcha. Okay.
It makes me so mad because you're going to have this thing in there that you're like, that's not what I really wanted to report. And that, my friends, is why we changed the message conf at the beginning. And what we really should have done is changed it before, like before we ever started pushing it in the IoT Hub. Apparently,
episode 1.
Yeah. So yes, now you've got your stuff under Eric's house. I guess we could create one called ignore or something like that. Go back to the instances, and there's one more thing we're going to do. So you've decorated the hierarchy. Now we want to decorate the actual data that we can plot here.
Okay.
So expand that, and then hit edit. And we only have to do it on the 2 that are of interest.
On this.
And go to properties. And now we're going to change it to instead be a default type, change it to an object detection type.
Oh, gotcha.
It's a weird thing to wrap my head around. Like this was all new to me, like this time series insight stuff. I don't necessarily know. Like I'm sure folks on this call or on this the live stream might be able to point us to like something metaphorically you can compare this to, but I don't know if there's something else like this out there.
Yeah, I'm sure it's based on other types of services, like, and that are, if you are constantly working with time series data, then this is probably a pattern that you recognize from some other thing that you use.
So we can totally like shape it to something. Now here's an interesting one too. So for name, you don't want this thing to be called street, Jetson Nano Zero. That's the freaking the partition key.
Right.
What you probably want to call it is like street or street camera, and you can override that here as well in that name field. And you'll notice that this is getting very, very rote. That's why it's not documented. It's like,
and then
maybe I'll update the docs, but in the module, anyways. Like, I thought about the amount of time it would take to explain this, to write this out, and it's just not there yet. So if anyone wants to help with that, if you do somehow come across the stream and want to update it, we accept PRs. Documentation is super valuable for us. So now you can go into Eric's house, select the tool, and yeah, now start plotting. And you'll notice, so you probably want to change the time window. So we're looking at last 24 hours. Let's try to zoom into that. So if you go up in the upper right, you should be able to like change that to say like last 15 minutes or so. Right. Sorry, that's like all the way in the upper right. See, it says last 24 hours.
Yeah. Oh, this is just like Grafana or something, right?
Yeah. And then do like a last 15 mins or something like that.
Last hour or something.
Yeah, that'll be better. And you'll notice it's going to blow up into it.
Oh, yeah.
And you can start making some sense out of this. Now, the only issue you're going to notice here is like, Eric, remember we threw a model at your cameras that detects like 80 unique objects. And right. Yes, unfortunately, you could write a funny query to catch all of those things, I'm sure, but you would probably have to actually go into the model and like, if you wanted to really see all 80 of those things, you'd have to enter them in. But you're going to see tomorrow when we do this with Power BI. Power BI is schemaless, so it actually doesn't care what we throw at it, and we'll draw it accordingly. So you'll see you're getting your data should look a little different than that.
Yeah, because I mean, I've had up here on the screen, I've had the office or the street camera going, and I see cars, so it's detecting cars and stuff. So I'm curious why.
Why would we not be seeing vehicles here?
Do you think that it is a capitalization thing because the label that is coming around on these boxes has car with a lowercase c?
Yep. It's 100% it. Yep. Let's go change that. Yep.
So, oh, go away. Okay, so that was in here, right? And then vehicle.
Yep. Why would you do this to us? But it's impossible for me to one size fits all this, and I think you see why, right?
And now is this the only place I need to update that?
No,
because it's also the detections too, right?
Yeah.
Car, truck. I'm assuming all of these probably need to be lowercase.
Yes.
Let's.
I hope this is the solution. I really do, because that wasn't.
All right.
I mean, logically, this makes sense. I'm a little concerned here, but yeah.
We're gonna find out.
And this is a hard thing. I was thinking about this when I wrote the lab. Like, how do I know what your model is? I don't know what your models detect at this point. Could detect dogs and cats. I don't know.
Cats trying to eat the other cat's food.
That's right. I don't know. So you will probably have to play around with this.
Did I modify
and now I think we see why.
I modified all these. Okay, so in theory,
that should just work. Do we need to refresh or something?
Do we need to do anything here?
Let's try to refresh and see if that gets it. Oh man, there should be more data. Do this. Remove all of these entities and re-add them. I know that seems crazy, but
wait. What are we doing here for that?
Yeah, you can hit the garbage can next to them. Yeah. All right. Let's just, because obviously the office has been seeing people, right? Oh, that's weird. Is it? Oh, okay, but that's our label. Okay, let's see what that gives us. Yeah.
There we go.
Dude, I was really nervous about that one. I know it made sense, Eric, but I had a feeling we were gonna drown on that one. That was cool.
All right.
Yeah. So, now, does your graph look cool now?
It looks so much better now.
Now, there's so much awesome stuff you can do from here, and the docs on time series insights, by the way, are like phenomenal. Like, they're very well written. If you go ahead and click on more actions. That was up there. Yeah, you can do all sorts of stuff. So you can actually connect this to Power BI. I don't like it though, because it's a snapshot. It's not live data when you do that. It creates a query.
So we have somebody in chat asking what we're doing. So this is actually part 4 of a 5-part series that we have been doing intelligent video analytics. So I'll switch over here. I've got some cameras set up, pointing out at the street, pointing out at me, and we are doing object detection on things that are found in the video footage, and we are collecting this episode. We're taking metrics from the things, counting how many cars and people we see, and then pushing that out and trying to see whether we can graph over time the number of vehicles and people and other random objects that are found in the camera footage.
Tirafat, did that answer your question? I know that's one. What did I just walk into?
Right.
We're building Skynet.
And if you follow along tomorrow from 2 p.m. to 4 p.m. Eastern time, we're going to be adding the next part of this where we're going to send it up to Power BI and some other stuff. It's been kind of a fun series.
So what is this? So now that you see the data, Eric, what are you thinking? I've nerd sniped you again.
Yeah, no, this is super cool. And now I kind of I wish I had a beefier device so that we could run the full YOLO V3 model to see kind of what the difference in detections would be, how much stuff is picked up that is not. I guess I wonder, I bet you we could probably find some things inside the office that I do know it picks up. Bottle that's been picking up, laptop, TV monitor, are all kind of things it's been picking up as well. So that would actually be kind of cool though, right? If we counted the number of TV monitors and laptops in the room, you could be alerted if that changed, right? Like somebody
Yes.
took the laptop out of the office.
There you go. That's a sick use case right there. And dude, like the difference between full yellow and yellow tiny that we're using is legit night and day. Like, I want to say I was gonna see if I had a picture of it. I was at a presentation somewhere in Seattle, and there's a whole bunch of people sitting in chairs and in a hotel room. And I'll be damned if it didn't count every single person, all of the chairs, all of their backpacks, the two screens on the back of the wall, and it's just like you're just seeing yourself like this is too
Wait,
scary.
I have to show you this. Hold on. Oh no, you're seeing it on the stream right now. It's detecting the truck as a train.
Yes, yes,
The Suburban is a train now.
that'll happen with the YOLO model. It will do that. You will find the degrees of accuracy will change with things, especially if it's not been specifically trained for that. But
well, yeah, and I mean in that particular case, you're not even seeing the whole vehicle, right? Like the front end
right.
of it's cut off, and it has to make some assumptions, and it's super dark, right? So,
But it's interesting because we look at this and you think like, what could we do to improve this? You're not that far off. In fact, all you have to do if you wanted to run full YOLO is get a device, modify this configuration to point to the YOLO v3 full configuration, deploy it, and your pipeline is still going to work. You don't have to change any of this. You're still going to report this data up to Azure. Like all of that still stays the same. You can swap in a device. There's nothing stopping that, which is really fascinating.
I'm gonna have to order one now. Aaron just asked, he wondered if we could point it at a crowd and detect whether people are social distancing or not.
That's a tough one because you have to do a lot of math up front. And what I mean by that is, so there's this thing you got to account for called a scale factor. So, and how your camera's looking. So number one, you would want, you could do that accurately if and only if your camera was in like a non-skewed fashion. Like you don't want to point it at an angle. Otherwise, you got to do de-warping to get it flat. You got to get it in the 2 dimensions. At that point, then you would apply a scale. You'd have to know like this camera and the things it's looking at, every, X amount of pixels is equal to X amount of feet. It's not impossible. You can totally do this. And once you do that, you can say, you would turn on the tracker in our DeepStream config, and that would tell you like, this is person 1, this is person 2, person 3. And you would then compute the distance of the bounding boxes around them, and absolutely at that point you could confirm social distancing. In fact, it's already being done. There's a top secret project I'm aware of that is totally doing that.
Yeah, and we did when we went into one of the areas in yesterday's stream, we did see somebody else's project where they were detecting whether or not people were wearing a face mask, which was super cool.
Yeah, there's a ton of use cases here, and now that you have the data too, I mean, it's like imagine you put this in a store. Well, you just or imagine you're at Ross dressed for less, or don't. I know that might be terrifying to some of you, but does the doorman really need to be there counting people, or could we just put a camera there? And then this brings up all sorts of ethical concerns, right? Like, are we automating away jobs and stuff like that? I mean, there's so much you could do here.
And I mean, you don't even really need a camera in those cases. You could just do like what Target does, which is just track MAC IDs of phones.
So while we're on the subject of how rad is YOLO v3, there is a demo I'll send over to you to bring up. This is it's running YOLO v3 on a HoloLens. Let's see here. YOLO, what is this? DeepStream.
And I think we're nearing the end of our presentation too. So if you have questions about things that we have built or maybe things you didn't see, we can hang out probably for a few minutes and answer some questions. I know there's a couple people here who have kind of jumped in at the end and are sort of playing catch up on what we're doing.
There's a couple examples here I'll give you that we can have playing in the background or whatever while we're talking about this. There's that one I just sent you, which is rather interesting. So that's using full YOLO, Terminator fashion. Essentially, what I mean by that is, if you've seen the Terminator movies, wearing a HoloLens and using that to detect objects and holograms. And there's also I want to show you this. When we were at Build, there's a Channel 9 video that kind of opens up with us pointing this at a crowd, and I think it's just going to blow your mind. Like when you see this thing working, it's night and day. It's just night and day. Looking for that video. Apologies.
I'm just sort of skipping ahead in this video to see. Okay, there we go. Oh, wow.
Yeah, I mean, it's nuts, right? Like,
yeah. Getting the bowl, the individual oranges in the bowl, the dining room table, the chairs, the bottles, potted plants. Wait, horse? The statue is a horse.
I don't get everything right, but yeah.
Dog. But yeah, I mean, so this is the full version of the YOLO model and not tiny.
Right. And there's the IoT show episode I think is really cool. This is us using it with a live cam.
Person.
If I could ever find this video.
Yeah, I think I want to get a more powerful device.
Oh, you've been sold?
Yeah. It's too bad it can't be delivered before tomorrow.
Well, maybe it can. And I know I sent you this on Slack, and it's probably like way back in our logs. So we chat a lot, but let me see if I can't find it there. I don't know. Yeah, there we go.
Paul's looking here. Did anybody have any questions or need us to kind of like poke back at something that maybe you've seen or didn't see because you just joined? But yeah, so I actually have a YouTube playlist of all of the episodes we've recorded so far. So if you've missed some, you can totally go back and even just skip through and browse through to kind of get caught up. And then tomorrow we're doing Power BI with all of this. And then our fun one on July 10th.
Yes. And there's more. There's I mean, like, we could, you've seen at this point, like there's so many things you could tweak. Like if we just change the model, or we just change the device, or we just change, this thing or that thing. It's just see, the very beginning of this video is interesting. This is using a live camera pointed at attendees of Ignite down in Orlando. And I think this will start out real quick. This is using the Jetson Xavier. So that was, yeah, look at that.
Wow.
Is that all we got? Yeah, I think that's all that it shows. But yeah.
But still, I mean, you're talking about, let me see if I can pause this frame. I mean, that's a lot of people and they're tightly packed. And then it's getting these bounding boxes of the handbag. I mean, the fact that all of these things are so close together and it's able to differentiate between them is actually pretty freaking amazing.
And so to the question about social distancing, like, yes, it would work. Like in this case, like imagine if this was like an overhead view and you did that rudimentary math that I was kind of explaining about calculating the distance. You could totally do it.
Yeah, if you knew the distance from end to end here in the kind of where the peripheral vision of this camera is, you could then use that to calculate the differences between these bounding boxes. It's a lot of math, but
if you keep playing it, there might be like literally right where you're at. It's just like, look at that. I mean, it's fantastic. And you definitely need to go to the end. Go to like the last like 10 or 30 seconds or so. Back a little bit. Sorry. A little bit more. Yeah, there you go. You just got Rick that's the one. Yep.
Wait, I think it just detected the micro. Was it a microphone or it said cell phone?
Cell phone, yeah, but it's still. I mean, it's.
I don't think artificial intelligence is taking over the world just yet.
Well, we're up to YOLO v5 and the map. So that mean average precision we were talking about yesterday,
Mm-hmm.
which for those of y'all on the call, that basically means how good a model is at seeing stuff it was never trained on. You know how high YOLO v5 is now? We were talking YOLO v3 was at 55. So 55% of what it's never seen, it can usually get right out of its 80 classifiers. YOLO v5 is 78%.
Wow.
What the heck?
So
That's
how do we get YOLO v5?
TBD, my friend. I think we can do it. And I don't know what's going on. They keep revving the numbers on them. PJ Reddy was the one who did the YOLO v2, YOLO v2, YOLO v3, and now I don't know if it's like been co-opted or something, because like in the last 3 months there's been a YOLO v4 and a YOLO v5. So we could throw YOLO v5 at this sucker and then start reporting your data up to Azure and things like that.
And Tirfat, you were mentioning that you think this sounds super complicated. I'm going to drop a link to the GitHub where you can follow along. And like I said, there's a playlist on my YouTube that has all of the past ones you can follow along. This actually isn't super complicated because we're not designing or implementing the models themselves or any of that stuff. This is actually wiring together stuff, and that was actually part of what this stream was to prove. This is Paul's area of expertise. I have actually never done anything with machine learning or any of these stream analytics or IoT edge products at inside of Azure. My background is I do have a programming background, and I'm a hobbyist electronics person. But this whole stream has basically just been Paul walking me through how to implement this stuff, and it's surprisingly fairly straightforward if you're just trying to use things that exist, right? Like object detection models. There's just some out there. Find one that works for you, or you can use some of the things that Paul has walked me through to kind of train your own model. And you don't necessarily need to understand the math behind implementing machine learning.
And I would argue that if you follow this, Eric can be a testament to this. If you follow these modules, you will know everything I know. It's end of story. I mean, it's true. I don't know anything other than this. There's a brain dump, this whole project. So Eric, I think you are going to be a designated expert after tomorrow.
I don't know whether I will say expert.
You'll have walked the walk, and I think that's enough to talk the talk, my friend.
All right, so I think we made it through all of this. Then tomorrow is Power BI, and then we take a small break, and then we have some fun with the engineers from NVIDIA and get them on and see what we can come up with there. That one won't be done on this Twitch account, but I'll tweet it out and stuff if you follow me. Maybe I can dual stream it to both, so that it ends up here too, which might be the smarter idea. But yeah, so does anybody have any questions before we let everybody go? And then we'll be back, same bat time, same bat channel tomorrow.
Sounds good. Looking forward to it all.
Just give a second here for some questions. I forget the delay sometimes.
I think we should make this our job, Eric. I don't know if we can keep coming up with content every day, but these have been like some of the funnest work days.
Sure we can. Right? Like, I actually want to do some embedded Rust development. And I've got a ton of stuff here. And years ago, I don't know, maybe 3-4 years ago, so I have all of the thermocouples and thermocouple amplifiers and all kinds of good stuff sitting over there because I barbecue. And I wanted to build a PID controller because I have like a big smoker, like huge, and just mounted a blower fan to it to stoke the fire for me. And so rigged something up, and it measures temperature of meat and all of that stuff. And it was just like a quick Arduino, Raspberry Pi, like little project, and I think it went to InfluxDB and Grafana, and I actually own bbq.live.
Of course.
So, and it's
Yeah.
just a Grafana dashboard of like all these temperatures. I think it'd be really cool to recreate that. Like, I can get all the hardware working, maybe on off streams or things like that, and maybe you can jump on to help me take all of that data and throw it out to Time Series Insight and Power BI. And I've always had this kind of cool thing, like, what if you took in all of that data? Could we start to figure out, like, predict how long something needs to cook or something? I don't know, but we can come up with stuff. We'll keep building stuff.
That is a promise.
So, all right. Well, thanks, Paul. Thanks everybody for joining. We'll see you again tomorrow at 2 p.m. Eastern time, 1 p.m. Central. All right, bye everybody.